Today we're going to take a look at how to solve quadratic equations, but in order to do so, we're first going to take a look at a graph of a function and talking about how the solutions to an equation are related to a graph, okay? So our warm-up is to graph this quadratic function here. Now, since we're in standard form, we're going to start by finding the vertex using x equals negative b over 2a to find our line of symmetry. So we're going to have negative b is negative 4 over 2 times a is 0.5. So that gives me positive 4 over 1, which is 4. All right, so my line of symmetry is x equals 4. And then I'm going to look at what is the y value that goes with that to find my vertex. So I'm going to do 0.5 times 4 squared minus 4 times 4 plus 5. And then simplifying that down, let's see, 4 squared is 16. 16 times a half is 8. And then minus 16 plus 5. So my y value comes out to negative 3. So that means the vertex is at the point 4, negative 3. All right, so now I'm going to start constructing my table. And I'm going to put my vertex in the middle. And then I'm going to start working with my reflection points. Now, because x is an integer, I'm going to stick with integers here. But because the a value here is a decimal, it's actually 1/2 as a fraction. I'm going to count by 2s to make it so that my computations are a little bit easier and I can avoid fractions or decimals for my y values. So I'm going to go with 2 and 6 first, and then I'm going to go with 0 and 8 next. Okay, now I'm going to plug in the 0 because plugging in 0 is almost always the easiest number to plug in. It just gives me the c value at the end because I'm going to get 0 for the x squared and 0 for the x. All right, so this is going to give me 0, 5, which means I also have the point 8, 5. Okay, so I'm going to plot those right now while I have the right color showing. And then I might as well put my vertex while I'm at it for negative 3. And now I need to do the computation for my other coordinate points. So I'm going to use the 2. So I'm going to do y equals 0.5 times 2 squared minus 4 times 2 plus 5. So that y value comes out to, let's see, 2 squared is 4. 4 times a half is a 2 minus 8 plus 5. So let's see, negative 6 plus 5 is negative 1. And then do the reflection point. So I have the point 2, negative 1. And what is it? 6, negative 1. And then I want to sketch my parabola. All right, so here we go. Now it's not going to be perfect. Make sure it looks rounded on the bottom. Mine's a little pointy here, so I'm going to smooth that out a little bit. All right, now there's my graph. Now we're going to refer to this graph in order to do the next part of this. So underneath it says, use your warm-up graph to approximate the solutions to the related equation 0.5x squared minus 4x plus 5 equals 0. Okay, so what is different between this equation and the original function? So the primary difference here, I had y equals in the original equation, and now I have equals 0 instead. So what does that mean? Well, that means find x when y equals 0. Well, what does that mean? That means find the x-intercepts, because x-intercepts happen when y is equal to 0. So if I go back and look at my warm-up graph, I see an x-intercept here, and I see an x-intercept here. Now we can only approximate these numbers because we don't have a perfect graph, all right? But we can see that it's definitely between 1 and 2. So I'm going to say that x is approximately 1.5. And then I can see on the other side, the reflection point for that is approximately, it's between 6 and 7. So we're going to say 6.5. Okay, so these are my approximate solutions, all right? In the next video, I'm going to show you how to get more precise approximations using a graphing calculator. See you there.